Okay, in this section, I went ahead and combined 5.3 and 5.4 into one set of notes. This is polynomials and operations with polynomials. So polynomial looks more complicated than it really is. This is the form. All right, basically what it means is you start with the highest exponent and you work your way down. So this is the highest exponent and this is greatest to least. Okay, so when I'm looking at this particular problem right here, if I'm writing it in proper polynomial form, then my highest exponent should go first, and that's this one. Then my next exponent is 2, so that should go next. Then the next one down, negative 2x, all the way down. Some polynomials are written in multivariable, which we're not going to do a whole lot with, but it just means the polynomial has more than one variable. Okay. Degree of a term is the sum of the exponents in the term. Degree of a polynomial is the highest degree of all the terms. And that's why I rearranged this one so that you can see the x cubed first. Leading term is the whole term that contains the degree. So going back up to this example, all of the 3x cubed is your leading term. Leading coefficient is the coefficient of the leading term. In this case, 3. You don't even see that. And degree 0 is a constant, so it's a number that doesn't have a variable. So in our example up here, it was the negative 5. You can classify polynomials by degree. That's the highest exponent and the number of terms. So we classify by degree if the degree is 0. Okay, so it's just a constant. It's literally called a constant. Degree of 1, so the highest exponent is 1. This is linear. Highest exponent of 2 is quadratic. Exponent of 3 is cubic. Exponent of 4 is quartic. And exponent of 5 is quintic. So 0 is constant, 1 is linear, 2 quadratic, 3 cubic, 4 quartic, and 5 quintic. Then by number of terms, one term, no addition or subtraction signs, just one term. The monomial. 2 terms, so there's one addition or subtraction sign. This is a binomial. 3 terms, so there's 2 addition or subtraction signs. This is trinomial. And anything more than that would be considered just overarching a polynomial, so it means many terms. These 3 are actually called polynomials too. They just have a more specific classification. It's kind of like your thumb is a finger, but more specific, it's a thumb. Or like your pinky is a finger, but more specific, it's pinky. So in these examples, you'll classify by polynomial and classify by degree. So degree and the number of terms. So example 1, it's 2 terms, it's a binomial. And I know it's 2 terms because it has 1 addition and subtraction sign. And the exponent has degree 1, so this is linear. All right, I have 2 addition and subtraction signs. This is a trinomial. Highest exponent is the 5, so this is quintic. So this is the degree. This is number of terms. (24). It is 1 term. You have no addition or subtraction signs, so it is a monomial. I also don't have any variables, so this is a constant. I have 1, 2, 3 addition and subtraction signs. So this is a polynomial. because you have more than 3 terms. Highest exponent is the 3. So this is cubic. Two addition and subtraction signs. This is a trinomial. Highest exponent is 2. It is quadratic. Remember degree. Number of terms. In our last one, there's no addition or subtraction signs. This is a monomial. Your negative sign at the front does not count. And its degree is 4. This is quartic. All right, so I pulled this directly from your assignment. Your assignment is in Delta Math for this. Okay, so this is the classification part. This expression represents, and it's asking for the degree. So the highest exponent is the 5, so this is quintic. With how many terms? It's got 4. The constant is the number without the variable. That is the 9. The leading term is the piece that actually has the highest variable. So it is all of that. And you can see I wrote it a little different. So it's x to the 5th divided by 2, which is the same as saying -1/2 times x to the 5th. And I say that because you need the leading coefficient, which is -1/2. All right. Adding and subtracting polynomials, guys, we have done this part, at least the addition. This is combining like terms. That's it. We did this in Unit 0, Unit 1, one of those two. Okay, in order for terms to be like, they have to have the same variable and the same exponent. These are considered like, but not those. You add the coefficients. The exponent does not change. Only time an exponent changes is when you multiply or divide. All right, so combine like terms and the exponents need to be in descending order. Okay, so I'm going to check for the highest exponent. So I start with the biggest one. So in this case, -8x cubed, positive 2x cubed. So that's going to be -6x cubed. And then I cross them out so I don't deal with them. Exponent 2. That's plus, this is a negative. So positive 3 and -7 is -4. Keep the variable and exponent. Then the positive 6 and the -3, positive 3. Okay, in example 2, the highest exponent is the square. And I've got another one here. So -3 plus 5 is 2. Then I have -9x. I got another x over there, so that's going to be -15x. And then positive 5 and -12, that's -7. All right, x squared's 1/2 x squared. Those are my biggest exponents. So you want to do 1/2 plus 1/5. You can do that in your calculator. That's 7/10. Then I've got -6x, -2x, so that's -8x. Then I have positive 1/3, -1/2, which is -1/6. Again, you can do that in your calculator. Okay, so let's see, squares. All right, so I'm gonna do it over here. I don't have my calculator handy, so I'm doing it by hand. Common denominator is 12. So it's going to give me -1/12. Again, do that in your calculator. negative 6x, positive 5x, negative x, negative 1/12, negative 1/3. So times 1 times 4. So it's going to be negative 5/12. Again, do it in your calculator. I'm just doing it by hand because I don't have my calculator out. Okay, so bigger ones. Let's see, 1.2x cubed, negative, there it is. X cubed is this time the biggest. So 1.2 minus 3.4. So 2.2, negative 2.2. Do it in your calculator if you're not sure. Next one down will be the square. There's a square there. .8, so negative 6.8. I don't have any x's over here, but I do have this x, so I'm just going to bring it down because I have nothing to combine it with. And then I have the positive 5 and the negative 7, so that's negative 2. All right, the highest exponent here is a 3, but it's the only one I have, so I'm just going to bring it down. Then I have negative 0.02x squared, negative 0.08x squared, so that's 10, so 0.10, .5x, negative 1.98x, 8 minus 6 is 2, 9 minus 5 is 4, so 0.42. Do it with a calculator if you're not sure. Negative 3.5 and positive 4 is going to be positive. Adding is easy. It is literally combining like terms. All right, subtraction is a little different. You have one step before you can combine any terms. Change all the signs of the second polynomial. Have to. And then it's combining like terms. So my second polynomial, change all your like terms. You're distributing a minus sign. Positive 8x, negative 12. And then it becomes combining like terms again. 7x squared, negative 5x squared. That's 2x squared. Negative 6x, positive 8x, 2x. Positive 3, negative 12, negative 9. Okay, change all the signs of the second polynomial. So negative 1/3 x squared, positive 3/7 x, positive 6. X squared. Again, doing this by hand. That's 15. So this isn't 1. Negative 1/2 x squared, or x and 3/7. Jeez, okay. Negative 1/2, 3/7. That's 14. So multiply by 7, multiply by 7, multiply by 2, multiply by 2. So this is negative 1/14 x. Again, do that in your calculator, guys. Make sure you include the signs. Positive 5, positive 6, 11. Change all the signs of the second polynomial with subtraction. Anytime you see that subtraction. So negative 4x cubed positive. Negative 10x squared, positive. Positive 5x, negative. Positive 13, negative. This time the largest exponent is the 3, which I have another one there. So that's 9x cubed. And your negative 15x squared, positive 10x squared. Positive 6x, negative 5x, which is positive x. Negative 3, negative 13, negative 16. Okay, change all the signs of your second polynomial. And I'm doing that because it is subtraction. If it's addition, you wouldn't worry about it. So negative 5.2x to the 4th, negative 1.6x, negative 7.9. Your first polynomial stays the same. You don't change anything about it. It looks like my highest exponent is the 4, which I have another one there. And you can do that in your calculator, which I'm doing this by hand because I don't have my calculator. I do not have an x cubed, but I do have an x squared, and that is the only one I have, so I'm just going to bring it down. I have a single x, so bring it down. Positive 0.3, negative 7.9. So 0.4. Last one. That's subtraction, so change all the signs of your second polynomial. So negative x to the 4th, positive 5.2x squared, negative 6.5x. Everything else stays the same. All right, so x to the 4th. So it's going to be 0.3 x to the 4th. X cubed. I think that's my, yeah. X squared, and that's my only one. So bring it down. And then 6.3x, and this is also, nope, not, that's negative. So that's going to be minus 0.2x. All right, so the key with subtraction is to change the signs of the second polynomial and then combine your like terms. Addition, straight into combining.